So quick discussion on built-in types. We've seen them all. I've discussed some of them already, but bool, right? And this is weird because bool is actually an honorific named after George Boole, the man who formalized rules of logic and rules of inference. So George Boole is why we call these Boolean variables. And we talk about Boolean logic. It's named after him. And why in a lot of languages, this is not a lowercase, but a capital B. Okay, because it's named after someone. It's a proper name. But in Python, it is, in fact, lowercase. Int, right? Integers. Float. String, str is string. In Python, you can use double quote or single quote. There's a subtle difference, but in all practicality, it doesn't really matter. List. So we can declare our empty list this way. Or we can fill it with data, and it can be filled with all sorts of data. A tuple, which is a immutable list. Okay. And we're going to see later on that behind the scenes, these are all the same thing, but they are presented to you in different ways. So we can declare an empty tuple this way, right? A tuple with no elements. A tuple with 3 elements can be presented this way. Why do we need this? A comma. Okay, well, let's take a look. Let's take a look at the alternative. Looks a little funny. I'm not quite sure why. What about this, though? If we want a tuple with 1 element, if we want an immutable list with a single element, and we put parentheses around it like this doesn't look like a tuple. What this looks like is grouping symbols for an equation, right? Parentheses from an equation. So if you want an ordered tuple of 2 or more, you can just do it the normal way. But if you want an ordered tuple of just 1 element, you have to put the comma after the 1 element in order to signify this is a tuple. I only want 1 element. I'm done. Okay. So that's a little quirky. We also have sets and dictionaries. Set is exactly like the mathematical concept. It is an unordered group of data where the data has to be unique. So you could have a list where every element is the same. You could have a tuple where every element is the same. You cannot have a set where every element is the same. It will reduce it to a single element. But notice this. In order to declare an empty set, you have to explicitly call the set constructor. Why? Well, because the empty dictionary is the double curly braces. If you put double curly braces, it will create a dictionary. Because in the dictionary, the keys are a set. So you have a literal set of keys, and each key maps to a value, right? If you say, hey, give me the value for B, it will give you 4.3. If you say, give me the value for 12, it'll say, sure. So these are the classic built-ins. I'm going to tell you, you're not going to see a whole lot of sets and dictionaries in this class. Being familiar with these is super important. Being familiar with sets and dictionaries is very important later on, and I wish we could get to these in this class. However, This is already a very full class and very full topic. So you'll see dictionaries more in Essential Algorithms 233. I think you see sets there too. You also get to play with sets a lot in discrete mathematics.